Hello everyone, I'd like to welcome you to the second screencast of the semester. So on Wednesday we talked about absolute dating techniques and we emphasized two isotopic radioactive techniques, potassium argon and radiocarbon dating, and we also started talking about dendrochronology. So today we'll discuss the history of tree ring dating in Arizona. So tree ring dating, or dendrochronology, was invented by A.E. Douglas. So originally he was actually an astronomer at the Lowell Observatory in Flagstaff, Arizona, which is now part of Northern Arizona University. And here you can see a photograph of Douglas standing next to a slab, a giant cross-section of a sequoia tree from California. And Douglas is the older gentleman on the left, and so he's showing the different rings and the types of historic events that they record, such as droughts, also such as fires. So as an astronomer, he originally worked with Percival Lowell and other colleagues at the Lowell Observatory, and they were interested in correlating tree rings with sunspot cycles. So the idea was that the droughts of the Southwest were correlated with sunspot cycles. And so what you could do is that if you could identify this correlation, match them together, then what you could do is, based on current sunspot cycles, you could predict droughts. However, archaeologists became very interested in his work, and they recognized that this kind of tree ring dating that he was doing could also be used to date archaeological sites in the Southwest. So first they recognized that it could establish relative dates for different sites. That what you could do is you could take the existing record based on the trees that you had, match that up with beams or posts or even charcoal from excavated sites, and you could figure out the relative record, and then by matching them up more precisely, you could actually establish calendar dates for those sites, when they were established, and also when those sites were abandoned. They also noticed, like Percival Lowell and Douglas, that those kinds of tree rings could also be used to reconstruct drought events and understand how droughts affected the organization and abandonment of sites in the Southwest. So unfortunately, Douglas had a falling out with Lowell. Lowell and his colleagues at the Lowell Observatory became very interested in the canals on Mars. So they thought these canals were part of an ancient civilization, and that idea became just really wacky. It became more and more difficult for them to get funding for the kind of work that they wanted to do. And so Douglas abandoned his work with Lowell, and they had a falling out. And he concentrated more of his effort on archaeology and working with archaeologists in the Southwest. So he began collaborating with archaeologists in and around 1914. And so what they wanted to do is they wanted to cross-date tree rings with beams from the ruins. So by matching them up with the existing tree ring chronologies that he had from living trees, they would be able to reconstruct climate records, and they would also be able to reconstruct time periods of these ruins. So their goal was to date sites and determine when droughts occurred. So when droughts occur in tree rings, as you'll see in a couple slides, the growth of trees, especially in the Southwest United States, corresponds mostly to precipitation and also temperature. So therefore, when it's really wet and temperatures are warm, trees grow more. However, when conditions are dry and also very cool, then what happens is that the trees don't grow as much. So drought years correspond to thin rings, and then good years correspond to wider rings. It's more or less the way it works, although there's considerable variation in that. And there's really complex algorithms because the growth cycles of different species of trees also vary. But now this is all very well understood by people at the Tree Ring Lab at the University of Arizona. So with a variety of different types of trees in a variety of regions of the world, they are able to reconstruct these chronologies. So by around 1920, they had established two chronologies. So one went from the living trees that Douglas already had all the way back to 1240 AD. So this established a record from the present all the way back about 689 years. But what they also had was what we call another floating sequence of 595 years that could not be anchored to a known date. So what they had is they had tree rings that couldn't be matched to living trees of today. So they couldn't be established to a current known calendar date, or they couldn't be matched to the historical record that they had. So because of this, the National Geographic Society funded several what they called beam expeditions to go around the Southwest to find beams that you see here, and to extract cores from those beams or to cut cross sections of those beams in order to find this missing link that would bridge the floating record that they had with the historical record. So with funding from the National Geographic Society, they began looking around the Southwest for these samples that would help bridge this gap and join the two chronologies. So they knew based on archaeology, they knew based on the sequencing of ceramics, that ceramic styles throughout the Southwest and the Four Corners region changed over time. But just like we did in the exercise in class on frequency seriation, they know that different ceramic styles were characteristic of different time periods. So they especially knew that early pottery was mostly red, and then later on it became more yellow. So part of this is based on where they were sourcing the clay for the ceramics, and part of it was also based on the type of trees that they were using in order to fire the clay. So they knew that there were areas that all from the present record were mostly what we would call yellow wares. Later wares using certain types of trees, and they knew that where they were missing this record, where this missing link would be found, would be in areas where they had primarily red wares, redder pottery that would predate the yellow pottery. So they identified a handful of sites in and along what's called the Mogollon Rim of Arizona, where they knew that they would be able to find these older beams. So one of the places they decided to excavate was a ruin in what's called Show Low, Arizona. So here it's the eminent archaeologists from the University of Arizona, Emil Howry, and two other men started investigating the site, sorting through, excavating the site, sorting through some of the room blocks that were in it, and digging through the material in order to find very carefully and precisely in order to find fragments of charcoal or fragments of beams. And you can read some of their accounts of this, of just digging through it, carefully sifting through the dirt that they dug up and finding just small bits of charcoal, and then all of a sudden they found a large dark stain. So they knew this would have to be some sort of charcoal, and probably a large piece of charcoal. Lo and behold, it turned out to be a very large piece of charcoal. It's a very large beam from the building that had fallen down, and it had been partially charred at the end. So this is great, because what it means is that if it's charred, that's going to preserve the beam very well. And what they would be able to do is to take a sample from it and identify its tree rings. And because it was large, so this meant that the larger the piece is, the longer the record will be, the larger the tree, the older the tree is, and the more rings it will have in it. So then they started getting very excited about this beam, and so they carefully extracted it from the ruin. They were able to make a sample. And then what they did with all their samples is that as they took each sample from a given site, they would give it a name and a number. So the first two letters corresponded to the name of the archaeologist who was digging it, and so it was HH. So this beam they labeled HH39. I believe this is for Hargreaves, who was digging with them, but I'm not exactly sure. So they dug out HH39, and they were very excited about it. And then later on that evening, Douglas came in from Flagstaff, Arizona, and he took a look at the beam, and he became very excited as well. So if you take a look at this beam, at this cross-section of HH39, one of the things that you see is you see this star. You see a star associated with it here to the right, and then you also see an arrow to the left indicating another ring. So from that star, that experts in this, they're able to quickly recognize these rings based on their width and also based on the sequence of those widths, and Douglas was able to quickly see that that star piece would date back to a drought that occurred in 1275, and that the arrow would correspond to a drought that occurred in 1247. So they know the dates of those two rings, and then by looking further to the left here, further towards the center, they were able to date that indeed this beam was cut down in 1237. So now they were very excited, because now that if it dates to 1237, it extends beyond the record that they had had previously, and brought in the possibility that this would indeed be able to bridge the gap. And so that's what Douglas did that evening. That what he did is he closely and carefully analyzed all the rings within HH39, and then based on the thinness of the rings, that tells you the severity of the drought. So carefully looking at each ring, what you could do is that you could measure, you could identify when a drought occurred. And so what they did is they worked just with simple pieces of paper here, and what you see up at the top is you see the old historical record that extended back to 1240 with the different droughts that had occurred and their sequence. Then the bottom piece of paper is a piece of paper that Douglas was working with. So by carefully looking at the rings, what he could do is he could indicate the occurrence of a drought and also the severity of the drought. And what you see is that the sequence of the drought and also their severities line up. He was able to line them up exactly between the old record on top, the historical record, and then the new record for HH39 on the bottom. And what you see that's absolutely critical is that the paper on the bottom extends further to the left. And then what he was able to do is that based on that, he was able to align the piece of paper on the bottom from HH39 with the previous floating record and then join the two together. So based on this sort of cross-dating, they determined that indeed HH39 bridged the gap and extended the tree record 585 years for the Southwest, from the present, then in 1929, all the way back to AD 700. So therefore they had a record. The other tree ring chronology now had a total record of 1,229 years. So this is very exciting for the community. There was a big article about it in National Geographic from 1929, where I stole some of these photographs that you see here. And it was a very exciting time. Established the longest record, that now what they could do is they could date all these sites in the Southwest United States, so know when peoples of the Southwest, ancient peoples of the Southwest, had arrived, when they occupied these sites, and also when they abandoned them, and how that corresponded to different droughts. So HH39 has been called the Rosetta Stone of Southwest archaeology. The eminent Southwest archaeologist who founded the anthropology department, actually first the archaeology department at the University of Arizona that I graduated from, he wrote, for the three of us, the experience was unforgettable. To be present at the instant of the celebrated breakthrough in science that set the chronological house in order for the Southwest United States was a reward enough. But beyond that was a privilege to work for a time at the side of Douglas, the scholar, the astronomer turned archaeologist. So Douglas later went on to establish the Laboratory of Tree Ring Research at the University of Arizona, more commonly called the Tree Ring Lab, in 1937, and he remained at the University of Arizona until his death in the 1960s. So there you go. That's the story of HH39. That's the story of dendrochronology. And for next week, what I'd like you to focus on is begin reading Chapter 5, pages 111 to 121, and be prepared to talk about the earliest hominins, the Australopithecines.